Imagine a world with no wind, no flowing rivers, and zero life. Just a totally still, frozen void. That dead silence would be our reality without energy. It is the spark that animates everything around us. In physics, energy has a very specific definition. It is the absolute capacity to do work, or to cause a change. This diagram shows what work actually means. It occurs when a directional force successfully pushes a mass across a specific distance. This scale measures that completed movement in a standard scientific unit called the joule. As the diagram scales up to measure larger, everyday amounts of energy, we convert those joules into calories, where 1 calorie equals roughly 4.18 joules. Practically all of this measurable, life-giving energy on Earth originates from a single, massive origin point, the Sun. The first domain of physics deals entirely with the behavior of large, massive objects. When an object is actively moving, it possesses kinetic energy. This chart compares a heavy truck and a small car moving at the exact same speed. Because kinetic energy depends on both mass and speed, the heavier truck outputs vastly more power. For an extreme sense of scale, the Saturn V rocket rapidly burned fuel to generate the pure kinetic motion required to push thousands of tons out of the atmosphere. But motion has a dormant counterpart. Potential energy is the stored power an object holds purely due to its position or condition. A heavy book perched on a high shelf, or the tension in a drawn bowstring, both hold vast amounts of potential power waiting to be released. Combine the two and you get mechanical energy. At the macro scale, all physical action is dictated entirely by this constant interplay of position and movement. Moving beyond solid objects, the second domain focuses on the invisible waves and flows that transmit power across space. Light energy is the sole visible form, acting as the crucial carrier of power across the vacuum of space to fuel plants here on Earth. Heat energy operates as a relentless, one-way flow, always moving from high-temperature bodies toward lower-temperature ones. Harnessing that exact transfer of heat, seen here as boiling water vents steam to push heavy pistons, drove the massive mechanical engines of the industrial age. Sound energy works by sending physical vibrations rippling through the matter in an environment. Together, light, heat, and sound act as the universe's invisible courier system. They carry massive amounts of power from a source directly to a receiver, without solid objects ever needing to touch. The most extreme forms of energy operate entirely unseen, down at the subatomic particle level. Chemical energy is the hidden power trapped tightly inside the microscopic bonds of atoms and molecules, waiting to break open during reactions. Electrical energy is driven by a continuous flow, or an imbalance, of electric charges. Drawing that unseen charge directly from the rails allowed electric transit to become the backbone of modern human infrastructure. Magnetic energy is the invisible force of attraction or repulsion inherent in specific metals like iron and cobalt. Today, we use that principle of magnetic repulsion to levitate Maglev trains slightly above their tracks, enabling friction-free, high-speed transit. The ultimate powerhouse is nuclear energy, derived entirely from either splitting atomic cores apart or fusing them together. It takes massive, towering structures like this cooling facility just to safely contain and harness the sheer force locked inside those microscopic atoms. These subatomic forces serve as the batteries of reality. The deepest well of power in the universe is hidden inside its smallest building blocks. Zooming back out, our active, buzzing universe is a complex web of all 9 of these domains interacting at once. But despite having 9 distinct forms, energy can absolutely never be created or destroyed. This continuous cycle diagram shows the core law of conservation. A nuclear reaction in the sun flows into a plant as light and chemical energy, which then fuels muscles to turn a mechanical gear. All action is energy transforming continuously from one state into another. So, if energy only transforms, where will the exact energy powering the screen you are watching right now end up next? Drop your wildest theories about that energy transfer down in the comments. If you learned something new today, hit that like button, subscribe, and ring the notification bell for more science. Every single action you take makes you a permanent participant in this eternal, unbreakable chain of physics. See you in the next one.